Everybody can hear me okay? It was one of those mornings, my wife's away on a trip, so I got up before to take my son to the rink. So I've had enough coffee now to make my hands kind of vibrate. The brain is not yet awake, so forgive me if I stumble over anything, doesn't hit me at the end. And it was funny seeing that picture again. That's the picture that my kids call the fat daddy picture. Also, I think I look like I'm about 25 without the beard, so whenever I want to get taken seriously, the beard comes back on. So if you're going to raise money or anything, it's better to do it when you actually look like you are old enough to be able to drive a car. So, MPD, so this is a great project. I have now been with Kodiak Copper for what I would describe as like half of that adult life. So I got involved with this company back in 2010. And we had a copper project in it at the time, and it was up in Alaska. And it was very exciting, probably the scariest helicopter rides I've ever been in my career. There was an ex-military pilot that was flying me around like Airwolf style, and I was afraid for my life. He also told me, which was interesting, that some of the planes that were on the tarmac at the military base in the middle of Alaska were actually made out of cardboard. So if the Russians or the Chinese are listening, here's a tip for you. We went from copper to diamonds. For many years, we were in diamonds. I met a lot of good people there, including Chuck Fickey. Had some adventures with him. Chuck taught me how to do heavy mineral surveys, and he taught me how to do some stream sediment surveys. That was very exciting. I once was sitting in the stream in the middle of Kelowna with him, and he didn't have a belt on. Things were showing, and we had an audience tracking us at that time. So. Some really good memories from the diamond days, and that's how I came across Claudia Tornquist. And she's an expert on diamonds. There's a very large diamond on her ring finger. So if you want to see a really big one, there it is. It's great stone. But we were thinking around about 2015, when it became clear that the diamond market was going to have a bit of trouble, we were scratching our heads and thinking about basically one commodity should the company go and focus on. And copper was the one that came to mind, because all the things that are now being talked about in the media about electrification and strategic metals and all these things were sort of brewing and percolating in the back of our minds. And back in my Imperia Metals days, I used to work at the Mount Polywine, which is in the Quesnel Belt in the middle of BC. And so that's how I sort of cut my teeth as a field geologist. They moved me around to different projects. I worked on some gold in Nevada. I worked at Red Chris for quite a while. Did the first kilometer deep drill holes there. And a really good friend of mine was my boss at Imperial Metals, Pat McCandless, a really phenomenal geologist, wonderful guy. And so Pat gave me a lot of leeway to do some scientific thinking when I was working for Imperial. I was thinking about where other copper deposits should be found along the Quesnel Belt, or Quesnel Trough, however you want to call it. And when we started looking for copper projects, this is why we went into this area, because there's a periodicity to these copper deposits as you migrate along the Quesnel Belt. And in this area, there was no major known deposits, but there was a lot of copper, early stage kind of exploration. And my boss, Pat, he'd actually been doing prospecting on this project in the 1960s for Newmont. That's what he told me anyway. I can't confirm it. And, so there was a project vendor that had assembled some of the claims in this region. And one of the biggest issues here, it's still kind of an issue today, was balkanization of land tenure. So when you looked at this area, if you want to build a critical mass on porphyry deposits around here, these Alcala porphyries, they don't tend to be that big, or these Quesnel Belt porphyries individually, but they tend to occur in clusters. And if you don't have a big enough land position, you're not going to have enough material kind of together. So there's always an issue that the land hadn't been amalgamated. But this prospector had collected sort of the Man, the Prime, and the Diddler claims all together, and that's why the project's called MPD. And subsequent to that, we've just systematically walked along and assembled other prospective ground in the immediate vicinity, and now, lo and behold, we have this really big land package, and we have lots of porphyry copper targets there. I should have maybe put this up before, and it probably should have had this while I was talking. So, the project is located Princeton Merritt. It kind of looks like we've got about half the land now between Princeton and Merritt in terms of strike length. Very easy to get to. Drive past here all the time on the way to hockey games or to check out the drill core. So easy to access. It's up on the plateau there. You can work all year, although we tend not to do the drilling in the winter because you've got to clear the roads. And to be honest, you need a little bit of downtime in the winter to digest what you've been drilling in the summertime and think about everything. So, but really, it's a well-established copper porphyry belt. Copper Mountain is really one of the more analogous deposits that's in the vicinity. Big, not the highest grade in the world, but in our case, we do have high-grade mineralized zones. And I'd actually seen some of these drilled recently at Copper Mountain as well, where you get into the sweet spots on these systems and suddenly the grade basically doubles. So the land size is about 338 square kilometers. And right now for zones, some of them are Man, Dillard, Prime, South, West, Addit, and Katchen. So we'll talk about all these as we go through the presentation. And the key here is the age of these rocks and the mineralization itself. And we're going to go through some slides where we've actually done some dating, and we'll give you the age dates, case things. So it's middle Triassic to early Jurassic island arc assemblages. I think most people know about the canal belt in that sense. There was an eastern migration over time of volcanism. So you get older stuff to the west and newer stuff to the east. It's summarized in the table there. The Copper Mountain suite here is probably the important one. If you look at those age dates from 204 to 200 million years before present, that's also the same age as our Poly. So we have stuff on our project that looks like those. Some of the rocks from this new Katchen zone that we've got now look exactly like stuff that we drilled at Mount Poly, for instance. It's really impressive. And, these porphyries, they all have similarities. This Gate Zone discovery, some of the rocks look just like what we were drilling at Red Chris with these sheeted quartz veins and the high-grade copper. So, all the similarities based on the deposit bars. So, moving along. So I think this is going to reiterate some of the points. I have to apologize. I didn't make the presentation. Usually I make these, but Dave was sitting over there looking up at the screen. Dave, if I stumble, it's your fault. So I'm going to read some of these, but the Copper Mountain Suite, very important here. The Wildhorse Suite to the east, the Brenda Mine is hosted in that. We're basically looking at intermediate composition volcanics and intrusives. So diorites, monzonites, monzodiorites, andesites, dacite, the volcanic equivalent. There's some big structures that run through the area too, like the Summers Creek Fault is probably something that's very important around the time of mineralization and has been reactivated later. There's typical alteration that you'd see in other BC porphyries here. Again, you could take rocks out of these porphyries and you could put them into other deposits and you wouldn't be able to tell the difference. So it's the same sort of potassic phyllic alteration, propylitic or argillic zones that you'd see in others. And there's a lot of copper mineralization for the stronger stuff that's associated with potassic alteration, which is also what you would expect to see. There was also moly. We've done some age dating on the moly. I'll show you that in a minute here. But you get some moly, you get silver with these zones. And because it's different magmas that have intruded and they're actually separate deposits, the chemical signatures and the geology are different deposit to deposit. It's obviously similar mineralization. This always stood out in my mind. When you think about the larger scale context, the image on the left is from the Andes. What's the commonality with looking at the Andes? Well, the main reason I put that slide up is because you get these sort of north trending structures and these northwest striking structures, and you get mineralization localized at prior section points. And, makes a lot of sense. The little cross section on the bottom shows you, obviously, you can't just pump a bunch of mineralizing fluids through solid rock. So you've got to do structural preparation, and the intersection points are going to be where you get posted mineralization. Well, these are not the same scale, these maps, but if you look at the one on the right, the scale bars go 5 kilometers long. And you can see there we have these two different dominant orientations of structures that run through the project as well. And lo and behold, at the intersection points, it's where we're getting these, these porphyry systems developed. And so pattern is very much like what you would expect based on these sort of large macroscopic scale structural controls. And this is kind of cool. we're in the plateau area. You'd figure everything is like, in terms of soil data, would be like highly transported. But man, like two things here. Number one, the project lights up like a Christmas tree. If you look at the copper and soil data, like it's really, really prominent. The other one is that, yeah, there is some evidence of transport in places. Other areas where we do the drilling, it's like 1-to-1. The base rock, the basement, the bedrock mineralization and the overlying like copper and gold in soils, it's like exactly correlated with no displacement whatsoever. So it varies area to area on the project, but for the most part, if you see the copper in soils, there's bedrock copper mineralization right under you. Very surprising to me. And this is some of the very exciting looking stuff. There are certain adult websites which feature very attractive people doing wonderful things. This is the equivalent in geology sense. So like, why do you drill this? Oh man, like I was getting like Jeff War, our VP exploration, was sending me these eggplant emojis on my phone. And it's like, well, what does that mean? And then I was like, oh my God. So that's from the Gate Zone discovery. You could see very intense silicification. There's intense chalcopyrite mineralization with boronite. It's easy to see on the left side. On the right side, you can see a lot of the stuff that you'd expect to see, the Kodiak alteration. In this case, it's actually overprinting some actinolite, magnetite, earlier mineralization. But the intervals here were pretty crazy. Like on the left side, that's a local interval of about 6.5% copper with almost 4 grams gold roughly over a few meters. But that's within a much bigger mineralized envelope. Like it's like, I think we had 500 meters of like almost 0.5% copper or something when we made that. And I've got that. I've got that somewhere else in here. And on the right, like those rocks, I could take them into Malcolly in places, and it would look exactly like what we were drilling underneath what the Springer hit. So again, the commonalities are pretty impressive. But you also see other mineralization, and you see a zonal pattern. We've got some 3D mock-ups of that too. But here's examples. Like this is an interval here. It was about 0.5% copper on the left and 0.5 gram gold. But that's within, you can see here, like it's basically boron chlorite veining. And it's like a late philic alteration overprint of that potassic alteration, which is, you can see this forming that sort of nested Russia ball model that you'd expect to see in the porphyry system. And on the image on the right, there's over 200 meters of 0.45% copper. And it's one of the funny things about this project. We will drill in some of these zones, and the rock doesn't look impressive, but it's carrying a lot of mineralization, like disseminated copper. It's actually impressively mineralized, although it doesn't look that impressive when you just stand back 20 feet and look at it. So that's biotite, magnetite clots with disseminated chalcopyrite and boronites. I hadn't seen that before, like looking at that really fine dissemination of boronite. That was pretty cool. So this is adjacent. If you look in the top right, you can see the little arrows pointing to some of the porphyry centers as we talk about them. So the man zone, which is on the left, that's actually got some really strong clay alteration overprinting the system that was there. And I described this as this would have been an incredibly high grade sort of pipe-like geometry early on, but then it had some argillic alteration that went over and basically overprinted some of it. It's or philic alteration, sorry. And you could actually see that sort of the lower temperature acidic fluid. I mean, it had eaten away some of the chalcopyrite, but that image on the right, that massive chalco, you can see these massive amounts of mineralization that are left in places within that. And we had some really good runs of grade actually going up to the near surface. So, this is like 0.5% copper over, I think that's a 20-meter interval, but we had like a few hundred meters of kind of 0.3 right from surface. So it actually has some pretty good grade, and I think it'll be important for the project or the future. The one on the, let's see here. No, that's Dillard on the left. That's the best interval for Dillard. The one on the right, the middle here is Man, and that is 0.34% copper over 100 meters there. And you could see, again, preservation of some of that those plots of really high-grade mineralization. Pretty nice looking stuff. And then down in the southwest part of the project, we've got the west zone here. It's geographically, the most western zone that we've drilled so far, pretty aptly named. But you have here a really sort of skarn-like association for the rocks. I'll try to move a little bit quicker, actually. But some really, really good grades, like almost 1% copper, and that's sitting over about 20 meters. But that, again, in the near surface, you'd get kind of 300 meters of grade in the 0.3 to 0.4% copper range. So really nice looking mineralization, but very skarny. And if you look at the picture on the right, you can see there's intense skarn alteration there too. So more skarn-like, pipe-like geometry, but also skarn-like. And then the added zone. We did some drilling on this last year. It's pretty cool looking stuff. Now, when the prospector guy was showing me around the project initially, he kept bringing me these rock samples of like malachite. And I was like, I don't really care about your copper oxides. I really want to understand like the sulfide grade potential. But this is the one area of the project we actually get high grade copper oxides as well. So it looks pretty cool. You're looking at a bunch of azurite here in these pictures, but it's not just copper oxides. Like when you're looking at, you get down below like the near surface zone, and you're actually in really nice grading sulfide mineralization as well. So there's an image on the left. So that's from this added zone, and there's some moly in this area too. So it's about 0.5% copper over about 50 meters here. So, and again, if you look at that image on the left, you look what I was saying before, you can get really good grades on this project without seeing a lot of really coarse copper. So Dave, we've talked about that a whole bunch when that core comes back. So then we look at this one on the right, you do get cloddy sulfide mineralization in places, but that's from a bit of a lower grade interval. But you can see bands of massive pyrite, chalcopyrite in strong quartz, sericite, pyrite alteration of the moss. So that's the added zone. And then we'll move along here to the south and mid zones. This is quite a big target on the project. Like it's a couple kilometers long. Down here. So this may be important in the future volumetrically for the amount of mineralization, but there's some weird stuff on it too. Like there's, you can see mineralized bedded tuffs, like on the right part of that image, pretty undeniable that that's a bedded tuff. And there's chalcopyrite. It's basically epidote chloric hematite with, copper-pyrite running along here. So we can see that. And I think, Dave, I don't remember the tops up. Did we actually interpret tops up from this stuff? I think it was upright, right? Yeah. So pretty interesting to have that information on the project as well. But here we actually did a drill hole, which the objective of the drill hole wasn't to drill for grade over the entire thing. The objective of the drill hole was to do like a low angle, kind of like, I don't remember the exact angle, but it's like 50 degrees or in that range. And it went for 1 kilometer and it was mineralized the entire way. So it was 1 kilometer of, wasn't super high grade, 0.17. The grade was concentrated in the top few hundred meters. And there it was like kind of in the 0.3 range, if I remember correctly. So it's a big system in this area. There could be a lot of mineralized volume around here, and something that we'll be doing resource work on coming up in the near future. So a little bit of the history of the exploration here, and this will give you some better ideas off of some of these high-grade intervals that we drilled. So in 2019, after we acquired the project, we went in and we began exploring this really quite an obvious drill target. And again, when I was being shown the project by the prospector who brought me all the malachite, one of the things I noticed was that there was just probalytic alteration like everywhere. And just thinking about a basic porphyry model with the probalytic alteration being on the outside, we started looking through some of the data. And we noticed that in this one area, there was a slightly deeper drill hole that had hit some potassic looking stuff, and the grades were getting a little bit higher. So we ended up drilling into this area, and we drilled, it was like the first hole was over here. If I look at the grade there, it was like, over 500 meters of high-grade copper mineralization. In the middle of it is pretty crazy. Like when you look at it, you have 50 or 60 meters of like 1.5% copper. So very impressive. And in that area, as we began to do the drilling, This is an example on the right that you see of that really tight correlation between the copper in soils and the underlying mineralized system. So this is the Kodiak Zone discovery. It's about 1 kilometer long, about 300 meters wide. And you can see like the pink, the copper in soils, exactly matches the area where we had underlying copper and bedrock. So really, really tight correlation. So very, very impressive that way, and quite surprising as well. Well, there you go, an animated arrow. That's very useful. Here we go, looking at some 3D blobs of the mineralization and the alteration in the Kodiak Zone. And if you could read the scale bar, which fortunately I read before I started doing this, the images on the left, each one of those little ticks on the bottom here is 50 meters, I believe. So you're looking at something with potassic alteration, which is like 500 meters long, and then it's got this phyllic halo around it, and around that you get the propylitic alteration, just like you'd expect. Some really, I was looking at this the other day, and I was actually thinking like there's a fault that runs down the middle of this, and it's got a really obvious sense of displacement on it. I was actually looking, if you look at the potassic alteration, you see that the phyllic alteration doesn't quite follow where the potassic alteration is. I quite wonder if you had the high temperature, high rate stuff come in, then if it had slip, and then an overprint of some of this, the later mineralization, that would be quite interesting. But very strong evidence that that's like, for timing wise, like basically a mineral structure. I think it's got some late reactivation on it as well. But there you go, looking at 3D, there's your chalcopyrite shells, and there's your pyrite shell around that. So again, very much like what you would expect. We did some basically a mobile element chemistry on here to bait that. There's an issue when you look at the rocks, like it's actually quite difficult to tell unit from unit. So we started to do geochemistry on these things to figure out what was what. And when you look at the bornite, the offset bornite center there, here's a picture of that bornite mineralization. Really nice high-grade blobby stuff. You can see the vanadium scandium copper plots. This is what it looks like in interpretation. You've got Unit A, a Unit B that runs through, and Unit A is mineralized, Unit B is mineralized, and there's a faulted contact in between the two here. So what that looks like is here. Here's an example of Unit A host rock with really nice mineralized veining running through it, and Unit B with very strong hydrothermal breccias on there. And then what is important here, so this gives us a chemical method to be able to distinguish between the two rock types irrespective of the alteration. But the dating is important. And earlier on I mentioned that there's a younging to the east of the magmatic emplacement in the mineralization. And if you remember, like the Copper Mountain mineralization is kind of like 200-ish MA. This is a little bit younger. So what we have here, you've got uranium lead dating of Unit B and Unit A, puts them at like 195 and 199 MA. And we did some dating of the moly mineralization that we saw as well. So what you got there was basically very similar ages. So it seems to confirm that the rocks here are range from about 200 MA to about 5 million years younger. And so the model that we built up for mineralization is this. Basically, 200 million years ago, had emplacement of the intrusions. You have alteration and mineralization of the country rock. And then 195 million years ago, you would get additional mineralization coming across this. And again, here's an example of the post-mineral faulting showing the chalcopyrite shells. So nearby, near the Kodiak Zone, about 4 kilometers away to the northwest, we've got this Katchen Zone, which is a recent acquisition for Kodiak. And we're quite excited about this because it has really nice grades in it, and that grade goes right to surface. Some of the interesting intervals here, like 266 meters of 0.26 copper, but that contains 78 meters of 0.5% copper.
108 of 0.28, but it contains 26 meters of a percent copper, 62 meters of 0.46, for instance, 20 meters of 1% copper. Really nice grade in the near surface. In the context of BC porphyries, we would call that high-grade mineralization. I don't think in the context of copper globally you'd call it high-grade mineralization, but certainly for BC, it's got nice grade in it. And there's about 15,000 meters of drilling here. I think on our project, we're at about 50,000 meters, aren't we? 85 now. Okay, so I was reading from the first slide. So we've done about 85. There's 15 years, so we're at 100,000 meters roughly of total drilling on the project now. Yeah. The interesting thing about Katchen from our point of view, if you remember the gate zone, it's about 300 meters wide by about 1 kilometer long. Katchen, as it's currently drilled, is already about 1.8 kilometers long and about 500 meters wide. So if you think about the area, just from a map view of the mineralization, it's about 3 times the mineralized area of the gate zone. So very important, I think, for future potential development of the project, and something that we'll be putting up resources on in the relatively near future too. Because the data quality from the drilling, I think, is 2015, and the data quality is really good. It's just an example of some of the important rock types. The important ones are on the bottom here, where you can see it's basically copper mount. Sweet. When you look at this, so these are examples of rocks from Katchen. It looks just like Mount Poly stuff. So typical alkalic porphyry, same age, same kind of rocks, and I wouldn't be able to tell the difference. If I drilled that stuff around like the northeast zone or any of the higher grade zones at Mount Poly, it would look just like this. So even if you look at the bottom left picture, there's like some sort of, it looks like a magnetite cemented breccia. One of my jobs at Mount Poly was mapping out the 3-dimensional facies of breccia mineralization at the northeast zone, so we could figure out whether it had offsets. We could hit continuations, which in fact we did, because you could see that the core of the breccia had these sort of fluidal clasts in it that were indicative of being close to like the underlying magmatic cupola. And by interpreting the fault structures there, we basically reconstructed where the mineralization would be at depth, and we hit it. So very interesting for me to see some of these same brecciated features. And as we do more work in this area, we'd love to figure out, if there's extensions or where they would be on that deposit. So we're beginning to do 3-dimensional modeling of the Katchen rocks. So you would see the example here of the copper shells in the gold color, and just the different units here relayed around it. So there'll be more information about this out in public as we do more work on the project this year. And here's a little bit of a compare and contrast between the gate zone and Katchen. And you can see there is an age difference of about 4 million years here. So the gate zone is a little bit more on the silica-rich calcalic side, whereas the Katchen is really more like a typical alkalic porphyry. So despite the fact they're 4 kilometers away, they're a difference of 5 million years, and really slightly different genetic models. We talk about this a little bit more, but we've done some whole rock data, and there's some plots up here. You can see where the different samples plot from the both zones. So here we go. MPD, what's coming up for us? Well, basically this year, as we've announced, we're going to start issuing 4301 compliant resource estimates, and because we're looking at a number of different mineralized zones, we're not going to be able to do this all at once. Some of the zones have enough drilling in them already to be able to put out resources. So that's probably the Gate Zone, the Man Zone, the Dillard Zone, and the Katchen Zone. And the other ones like the West Zone at it and the South Zone that I talked about before, where we did the kilometer-long hole, those are going to take a little bit longer and a little bit more drilling. So we'll probably start drilling on those this summer. The other ones will be able to issue resource numbers sooner. What I could say about this, looking at it ahead of time, is we have delineated a big volume of mineralization. It certainly has potential to be billions of pounds. What we have to calculate is how that mineralization, how much of it fits in pit shells, and then we'll see what we can issue that way. But it's a relatively big system actually, and because it's multi-center, it'll be interesting to figure out conceptually like how these things would be potentially operated together or developed together. So there'll be, data from all of these historic zones is going to be used to develop these exploration block models. The models are going to be interpreted by lithology, alteration, distance or intrusive grade shells. It's different criteria because of different generations of data at each deposit, but that work is going quite well. We have pretty good controls over, especially the stuff that we did. And, we're going to be looking at basically some of this additional targeting that we have as well. Like we've been working with Verify on the AI side to develop additional drill targets, and those are going to be further explored this year. I'm finding with the AI data, it's quite interesting. Like it's able to see prospective rocks, but it's less able to see at this point the difference between the highly mineralized prospective rocks and just say sulfide mineralized prospective rocks. So in this project, especially, you get these big pyritic halos. So it definitely is able to see those. It has not vectored in yet on the more highly mineralized stuff yet. So as we feed more data into the AI and train it more, it should get even more accurate in defining areas that are of higher potential for higher grade mineralization. So we'll continue the exploration. We'll do resource delineation drilling, and there'll be ongoing field work like soil sampling, prospecting, and all that as well. So I guess I'll wrap it up. That should be about it. You can always contact the company if you have any more questions, but now's a good time if you want to ask me or any of our guys here. So that's it.